Okay, we're still in chapter 5, explaining continuity, the second subject in the chapter. Here we have some extra exercises to understand continuity very well. Number 1, we have a piecewise function f of x equal 3 parts. We want to determine if it is continuous or not. So the question is the piecewise function f of x continuous? So to determine that, we need to satisfy the conditions of continuity. First condition, finding the limit. So we need to check L1 and L2. So we come now to the value of the crucial value, or the critical value, is 2. So then when x is less than 2 and greater than 2, we can check it by limit, saying that L1 is limit the function f of x when x approaches 2 from the right. From the right it is 2x squared minus x. So we will substitute the value of x, and then this is 4 times 2 is 8 minus 2, it is 6. Also L2, substituting the value of 2 by the value of the function for x from the left, for 2 from the left. So this is x cubic minus 2, and the result also is 6. Then L1 and L2 are equal. This is for limit. Completing the condition of continuity needs to substitute the value of x, the critical value of x, in the function. And thus we have it in the definition of the function x equal 2. So f of 2 equals 6. And 6 is the same of the limits of the function. So then f is continuous at x equal 2. On number 2, we want to explore the continuity of this function. Means that the function is given. We need to check is it continuous or not. We have the function defined on 0, 3 closed interval, and we want to check it on x equal 1. So the point is given. I know that 1 belongs to the closed interval 0, 3. So then I take the function. Firstly, if we substitute 2 times 1 is 2 minus 2, thus will make the denominator 0 and the function will be undefined. So we need to use the extension of the function, so we will factor the numerator as difference of 2 cubes. Here is the factoring, and take out 2 as a common factor in the denominator, and now we can remove x minus 1 as a common factor, and this is the function now. So the problem of the denominator has been solved. Now to check the continuity, we will take L1. Thus when x approaches 1 from the left, and here is the substitution of the values, and we will take L2 when x approaches 1 from the right, and here is the result. I just want you to know that here I just wrote x's, and this is in L1, and L2 I wrote the substitution values. So it is the same thing, and that's why I made them in 2 different ways. In the truth, they are just a extra step. At the end, both are equal to 3 over 2, so the limits are equal. And if we substitute 1 instead of x in the function, this is going to be 1 plus 1 plus 1, which is a 3 over 2. So g of 1 is a 3 over 2, and then the limit equals the function at the point 1. So g of x is continuous at x equal 1. On number 3, we want to explore the continuity. Means that we want to check if the function is continuous or not. The function f is defined from R to R, and the function is an absolute value of 2x minus 6. In this case, we open the function related to the definition of absolute value. So 2x minus 6 equal the positive case and the negative case. What about the crucial point? How did we find it? We just say on the side 2x minus 6 equals 0. Then transfer 6 and divide by 2. So the crucial point is 3. So then the positive case is for x greater or equal to 3. And the negative case is for x less than 3. And that's in the definition of absolute value function. Now if I want to check the continuity, I need to check the limit first. So limit of the function as x approaches 3 from the right is limit of 2x minus 6, which equals 0 if you substitute 3 here. And limit f of x as x approaches 3 from the left is negative 2x plus 6, and also as x approaches 3, this is negative 6 plus 6 and equal 0. So then L1 and L2, they are equal 0, so the limit is found. Now we need to check the continuity, means that we have to satisfy the second condition of f of the function. As x approaches 3 means that we need to use x equal 3, So f of 3 equals 2 times 3 minus 6. 6 minus 6 is 0. And then the limit equals the function. So f of x is continuous at x equals 3 because the condition satisfied. The same thing on number 4, but with little different idea. I have a function f. F of negative 1 equals 5. And I have the formula of the function f of x equal 2a plus x squared and 2x plus b. And the critical value or the crucial point is given. So I have a function f with image 5 for negative 1. I have the formula of the function, and also I know that this function is continuous on x equal 1. Now I want to find the values of a and b, which are written here in the function formula. So as we know, because I know that f of negative 1 is 5 and negative 1 is the value of x that is lying in this part of the function, so f of negative 1 is 2 times x, which is negative 1, plus b. This equation equals 5 given, and then I can find the value of b, which is 7. So I found the first missing value in the function. What about a? To find a, I will need to use the definition of limit, because you know that f is continuous. So limit of f of x as x approaches 1 from the right must be equal to limit f of x as x approaches 1 from the left. Approaches 1 from the right means that 2x plus x squared is here for the limit and equal to the limit of 2x plus 7, thus for 1 from the left. How did we find 7? This is b, the value of b that we found is substituted here. And both of them are polynomials, so we can substitute the value of x. So 2a plus 1 equal 2 times 1 is 2 plus 7 is 9, and then a equal 4. On number 5, state the continuity for f of x. State the continuity means check the continuity. The function f is given from R to R. So the critical value or the crucial point is 1. So this is the crucial point. To check the continuity, I need to take the limit from the left and from the right. So from the left, as x less than 1, this is 4x plus 1 equal 4 times 1 is 4 plus 1 is 5. And from the right, this is the function 6 minus x squared, which is 1 squared, and the value is 5. Thus the limits are equal. To complete checking the continuity, we need to substitute the value 1 in the function. As x equals 1, the function is 6 minus x squared. So f of 1 is 6 minus 1 squared, and this is equal 5. Then the limit of the function equals the function at x equals 1, so the function f is continuous at that point.